Okay, welcome everyone. My name is Jan Gurda. I work in Speed project, and in this presentation I will give you a general overview of Amazon Web Services, and I will mention a little bit about global infrastructure, how Amazon infrastructure is located around the world. Our agenda for today is first very quick introduction to Amazon Web Services. I will show you Amazon Web Services console. Later I will list most important services, but this is my subjective list. I look at Amazon Web Services, how they are important, looking from our own perspective, from looking of perspective of my team. Later, I will show you how on-premise infrastructure. So on-premise infrastructure is infrastructure you keep in your data center, maps to Amazon Web Services, to particular services of exposed by Amazon. Later, I will mention a little bit about a shared responsibility model. This is responsibility. This is shared responsibility of keeping your system secure. This responsibility is shared between you and Amazon. And later we will talk about Amazon global infrastructure. I will tell you what our regions are, what is availability zone, what is difference between a single availability zone and multi-availability zone deployment, and at the end we will mention edge locations. Okay, so who is this presentation for? This presentation is for everyone interested in Amazon Web Services, but you must at least have some knowledge, some general knowledge. What is Amazon Web Services in general? But if you don't have that knowledge, I believe you also will benefit from this presentation. So we can get started. First, before I will talk about services itself, let me show you Amazon Web Services console to show you how many services does Amazon actually expose. Okay, so as you can see, Amazon Web Services provides a bunch of services. There are dozens of these services. Each service is designed for something else. They are grouped by similar features they provide, like storage and content delivery, computing, developer tools, management tools, application services. It's really hard to be up to date with all these services because they change very rapidly. They are backward compatible, of course, but new services appear. For example, Elastic File System appeared recently. Internet of Things was announced during last reInvent. Mobile Hub was also announced not so long ago. Inspector. So number of services is rising, and this console. This is console, which is graphical user interface entry to all Amazon Web Services, and it presents all of services. It also gives you possibility to set up these services, to customize these services according to your needs. Of course, not everything we may do through console, but I will discuss that maybe later during different presentation. Let's go back to our presentation. Okay, so first, most commonly used services, but this is my subjective list, and these are these services I will present. I will show you a quickly overview. Are chosen by potential gain they may provide to our team. So we don't use all of them, but we may use some of them. We are thinking about using some of them. So let's start the most famous, the computing power Amazon provides. And just a digression here, each Amazon Web Service is identified by appropriate icon. This is something interesting. So each service in console I showed you has its own dedicated icon. For looking from computing point of view, we have three services which provide computing power. This is EC2, Elastic Cloud Computing, Elastic Cloud Computing provides scalable, scalable computing power, on-demand computing power, flexible computing power, so you may adjust computing power you need. It may be, you may think about it as some kind of virtual machines on demand in a cloud. So when you need a new machine, you simply set up new EC2 instance. It's provisioned in minutes, so it's quite provisioning delay between requesting and provisioning is very short. It's 2 minutes. In the next presentation, I will set up two EC2 instances, and you will see how fast these EC2 instances are set up. Another service, EC2 container service. Container service because it uses Docker inside. So Amazon built some kind of abstraction over regular EC2. They provide appropriate interface to deploy Docker containers inside EC2 instance. With EC2 container service, you don't have to set up Docker manually, install Docker manually. You only need to point which Docker container should be deployed on particular instance. You choose instance size. And Amazon simply does deployment for you. I don't know how it is now, but in initial release, you could deploy only one Docker container per EC2 instance. I believe they changed it somehow since that time. Another service is Amazon Lambda. Amazon Lambda is also a computing service where you can upload your code and the service can run your code on your behalf using Amazon infrastructure. This Lambda computing service could be very helpful, for example, for processing images. So when you upload images to S3 bucket, you may configure S3 bucket to notify Amazon Lambda about this event, and Amazon Lambda may process this image or put it to database or calculate hash or something like that. So this is more like event-driven processing. EC2 instances and EC2 container services are priced per hour of running. So you set up instance and you pay per hour. Lambda pricing model is a little bit different because you pay for memory you used and time your Lambda function, because the code you upload is called Lambda function. You pay for time the Lambda function runs, so you don't have to set up infrastructure. Amazon sets it up by their own, and you only pay for CPU cycles you used and for memory you used. Okay. Storage and content delivery. So the most famous, and it was one of first Amazon Web Services, is S3, Simple Storage Service. This is object store. It allows you to upload up to 5 terabytes objects. According to Amazon, it has no limit, so you may upload as much as you want. But you must remember you pay for all of that. So you pay for data transfer out of S3, so when someone downloads your data, you pay for storage. You pay a few cents per gigabyte for storage. And you pay for requests to S3 buckets. So, for example, when you expose some of S3 resources as static resources for your web page, you pay for each request your web page client does to download, for example, images or static content from S3. This price is not big, but it's not high, but when you have high traffic, it gets quite. You may get quite a big high bill. But for small and for small sites and medium sites, this is relatively cheap solution to store to store your static data. But it may happen that at some time you uploaded something to S3, like financial report, like medical data and this kind of stuff, and you don't want to pay so much money for keeping that data there. So there is another web service called Amazon Glacier. Amazon Glacier is a simple backup service. So you may you may take your data from S3 and put it to Amazon Glacier. So Amazon charges low price for storing gigabyte in Amazon Glacier is lower than in S3. It has also some nuances with pricing for some, because you pay for recovering data. So for storing data is price is very low, but for recovering data is quite quite high. I will not go into details of that. CloudFront is content delivery network. So CloudFront brings your static resources closer to your client. In a few minutes, I will discuss about global infrastructure. Amazon has a few data centers around the world, but besides these few data centers, they have also few locations called edge locations throughout the world, where these static resources are cached and they are closer to your clients. So Amazon has, as far as I know, Amazon has edge location in Warsaw. So some static resources from S3 may be cached in Warsaw, so they are closer to your clients. And EBS, Elastic Block Storage. This is a service which provides block storage. So S3 is object storage; you put objects there. But EBS, this is block storage. Like you may think about it as virtual hard drive. So when you provision virtual hard drives, you may attach them to EC2 instances. From databases point of view, Amazon provides RDS. RDS is a managed relational database management system. Underneath, you may run Postgres, MySQL, Microsoft SQL, Oracle, MariaDB was announced recently, and of course, Amazon's implementation of MySQL is Aurora. It depends on what you need. You may choose appropriate engine, but Aurora looks the best so far because it allows you to keep up to, I don't remember well, but up to 64 terabytes of data. All other solutions may allow you to keep up to 6 or 4 terabytes of data. It depends on particular engine. DynamoDB is NoSQL data store written by Amazon. You may think about this as like for MongoDB or Redis or this kind of things. It's slightly different. Data model is slightly different than on MongoDB, but there's good analogy between DynamoDB and MongoDB. Elastic Cache is caching solution. Underneath, service is called Elastic Cache, but underneath you may run Memcached or Redis. Redshift is petabyte scale data warehousing. So if RDS is appropriate for online transaction processing, Redshift is appropriate for data analysis, for analysis of big chunks of data. You may integrate Redshift with your own analytical tools. That is basically all about Redshift. Very, very brief overview. We don't have much time. Networking, VPC, Route 53, and Elastic Load Balancer. VPC is used to configure subnets inside your Amazon account to configure logical thing like virtual private cloud, which is part of Amazon where you operate. Everything what happens with EC2, Elastic Cache, RDS happens inside VPC. VPC allows you to split this big namespace, this big space into smaller subnets. and define rules of connection between these subnets and rules of going outside and inside subnet from internet. Route 53 is simply DNS service which integrates well with other Amazon Web Services. Elastic Load Balancer is very simple load balancer which allows you to balance traffic between your EC2 instances or EC2 container instances. Yeah, that's basically that. Security and access management. There is a service called IAM. It's global service. It allows you to define permissions of end users which have access to your Amazon resources. I will discuss more about IAM in next presentation. Application services, simple queue service. This is, as name says, it is queue service, but managed by Amazon, so you don't have to worry about infrastructure. The same about SNS, simple notification service, is also managed by Amazon. This is if SQS, you may think about queue, point-to-point communication. For SNS, this is one-to-many, so this is kind of topic communication. Simple email service, this is emailing service which you may use to send emails to your customers. And Cloud Search, this is also service managed by Amazon, so you don't have to worry about infrastructure, about maintaining infrastructure. With Cloud Search, you may run some kind of searches inside your web pages, inside your big chunks of data. We may compare that with Elasticsearch or Sol or other searching solutions, but with other searching solutions, you must maintain actually infrastructure. Management tools, CloudWatch. This is some kind of metrics service. You may publish metrics to CloudWatch, and CloudWatch keeps that metrics for you, draws charts and this kind of things. So you may use CloudWatch to measure performance of your application, applications, of your resources. It integrates well with other Amazon resource services. CloudFormation, this is DevOps service. It allows you to automate deployment into Amazon. It supports JSON format of scripts, but that's all you should know from this presentation. And CloudTrail is auditing service. So in CloudTrail, any user changes something in your account, in your Amazon resources, appropriate auditing logs are sent to CloudTrail, and later you may watch these logs. Okay, and how on-premise infrastructure maps to Amazon services. So on-premise infrastructure, you have some DNS services, some web servers, some LDAP servers, some data storage with replication, with backups. You have disaster recovery site. You have firewalls. You must provide power supply, internet connection. Of course, that would be nice if that was redundant. You must think about many different things when you're running your own data center. So how does this on-premise infrastructure, this maps to Amazon Web Services? So how to start thinking about moving your own data center into the cloud? I prepared this kind of table which for every technology stacks proposes Amazon solutions. So for computation, in your data center, you have physical servers, you have virtualization. In Amazon, you may use EC2 instances, Lambda, or EC2 container service. For storage, you have physical disk, of course, SSD, SCSI, SATA. You have NATs, SANs, and this kind of things. In Amazon, you have S3 to store some of your data. If you need block storage, you may provision appropriate EBS volumes. But EC2 instance itself, some types of EC2 instance, also have its own instance store, which also may use as you may use as a storage. But this instance store is ephemerical. So when you terminate the machine, it is lost. So it's for preserving data, it's best to keep this data on EBS or S3 or Glacier. For network, you must maintain your physical routers, VPN, virtual LANs. You must have physical cables which you connect to form nets, subnets. You must configure these routers to form subnets. In Amazon, we have VPC, we have Direct Connect and VPN services. I've already mentioned about VPC, but Direct Connect allows you to connect your data center to Amazon. And VPN allows you to connect your office to Amazon. So you may connect to Amazon through VPN. Content delivery, there are a bunch of content delivery network solutions throughout the world, which take your resources closer to your customers. And in Amazon, you have CloudFront. From database perspective, you must provision your own servers with databases running. You may choose Oracle, Postgres, many different databases, even NoSQL databases like MongoDB. In Amazon, you don't have to care about infrastructure. You may provision RDS instance with Oracle, Postgres, MySQL, and other engines I was talking about. Or you may use DynamoDB for NoSQL. There's one digression I must mention here because that was not strictly said. By getting rid of this physical servers, of these physical beings like servers, routers, you must pay a little bit because when you have physical server, you have it, you paid for that, and it's your own. In Amazon, you pay for that. Each service is priced appropriately, so that is a difference. For load balancing, we have hardware load balancers, Cisco F5. Amazon solution is Elastic Load Balancer. DNS, various DNS providers, and Route 53. For Skylink, we have hardware and software clustering, like Apache Zookeeper. In Amazon, we have auto-scaling groups, custom software clustering. Similarly, from analytics, we have Hadoop, Cassandra set up on our own servers. We may use Elastic MapReduce. For messaging, we may set up TIBCO, RabbitMQ. In Amazon, we have SQS, Simple Notification Service. Caching, the same, Memcache, Redis, Elastic Cache. But underneath Elastic Cache, there is Memcache and Redis running. But you don't have to worry about infrastructure. For archiving, Type storage, it's the cheapest one, and Glacier, Amazon alternative. Shared responsibility model. So when you deploy something to cloud, when you deploy your application, you cannot rely only for Amazon to make your application safe, to make your data safe. And Amazon introduced something like a shared responsibility model. There is something like security of a cloud and security in a cloud. Security of a cloud is responsibility of Amazon. So Amazon is responsible for keeping safe of their data centers, or keeping safe of disk and this kind of stuff. Security in the cloud, you are responsible for keeping your application safe. Here are sample responsibilities which Amazon and which belong to Amazon and which belong to you. So Amazon, for example, must guard their data centers, must provide two-factor authentication, disk destruction, network monitoring, intrusion detection, and safe API. And your responsibility is, when you use EC2 instance, to patch your OSs, to audit logs, to prevent malware and virus infections, to at some point to schedule backups and to create backups, to keep your network access strict. I mean, to prevent from unauthorized network access. So there are two separate things. What Amazon must do to keep cloud secure, and what you must do to keep your application secure. Global infrastructure. As I said at the beginning, Amazon has few data centers distributed around the world. Currently, there are 11 regions. One of these regions is dedicated to US government cloud. To US government, actually, it's GovCloud. It would be nice if we had also Amazon infrastructure for Polish government, so we would not have to pay millions or billions of zloty to maintain various different infrastructure for different systems. Region is actually completely physically isolated location in a particular part of world. So regions are completely isolated from each other. They have so when one region fails, another regions are not affected. Regions consist of availability zones, which I will mention later. It's really difficult to find what is actually region. So does it consist of a few data centers or data center divided with some kind of fire-resistant wall? It's Amazon keeps that as a secret, and Amazon doesn't want us to know that. Amazon doesn't want us to go into details of that. How do you choose region? So we may choose region, but of course by latency. So the closest region, the smaller latency for our clients to download data to be served. There's also legal compliance. So for example, some fragile data you cannot store in, according to Polish law, on US servers or Japan servers, on this kind of thing. So this is legal compliance. There are many programs like Safe Harbor between US and European Union, how to keep personal data safe. But for legal compliance, you may be forced to move your data into our region. Of course, cost for different regions of different resources in different regions is different. So you may pay for a particular EC2 instance 12 cents per hour in US and 13 cents per hour in Ireland. This depends on power costs, on land costs, because Amazon data centers must be built somewhere. So this depends between regions. And features. Some features available in one region may not be available in other regions. But looking at how these features appear in different regions, Amazon tends to have all features be available on all regions. Region consists of multiple availability zones. Minimum, there are 2 availability zones. Maximum, there are 5 currently. Each availability zone is physically isolated from each other, but they are close to each other. So, we may think about that as 2 data centers close to each other, connected with private links with very high bandwidth and low latency. And availability zone is designed as independent failure zone. So when one availability zone goes down, other availability zones are up. So these are all regions available. I mentioned that there are minimum 2 availability zones. In China, I believe second availability zones has already appeared. Okay. Some services are global, some services are regional, some services are availability zone specific. So global services are identity and access management, Route 53, and CloudFront. They are global, so when you add user in IAM, you see that in all regions. When you add route in Route 53, you see that in all regions. Some services are regional, so for example, S3 is regional, so you create bucket and you see that this bucket only in one region, and Amazon is responsible for keeping that data safe in this particular region. So when you switch to different region, Amazon, you don't see that bucket because it doesn't exist there. And EC2 instances and RDS instances and Elastic Cache instances are actually availability zone aware. So when you deploy EC2 instance, you choose availability zone which this EC2 instance running in. What is the difference between multi-availability zone and single availability zone deployment? Single availability zone is not highly available. So when one data center, let's say it's data center, when one availability zone goes down, whole your system goes down. But it of course provides a lower price because you pay only for resources in one availability zone. But it provides limited scalability. Amazon, in their documentation, they say that at some point a capacity of particular availability zone may be filled, and you may no longer be available to deploy new resources there. From the other hand, we have multi-availability zone deployment. So we have one machine in one availability zone and second machine in second availability zone, or we have RDS instance in one availability zone and read replica in second availability zone. It provides higher availability and disaster recovery, but with a cost of higher price, but it provides better scalability. So this is just a picture showing multi-availability zone deployment. So we have two servers in two different availability zones. We have database, which we have read-write replica in one availability zone and read replica in second availability zone. When availability zone 1 goes down, Amazon automatically switches zone 2, read replica to read-write. There's, of course, one more level of high availability and disaster recovery is a multi-region architecture. So you deploy a mirror of your infrastructure in two regions, and you use Amazon Route 53 to drive traffic to one region or to second region. But this is a very costly solution, good for big enterprises, for large companies, which must maintain very high SLA. And it's quite difficult to achieve to work correctly. And the last topic, edge locations. Amazon has about more than 50 edge locations distributed throughout the world. As I said, they are also in Warsaw. Edge locations are responsible for getting your data closer to customers. So it may cache some static resources from S3, but edge locations are also responsible for DNS caching. So DNS itself is distributed database, and Amazon distributes that even more with their infrastructure because they don't maintain that only in their data centers, but they distribute it across the world inside edge locations. And that is basically all. If you have any questions, just ask. Okay, thank you.